AI winning a Nobel Prize in physics. Not something you see every day, right?
Mm.
Definitely caught me off guard. I bet it raised some eyebrows out there, too. And you know what that means? It's time for a deep dive. Get ready, because we've got some really interesting stuff to unpack here. This isn't just about algorithms and equations. We're going to be talking about a tech giant's rise to the top, those aha moments that changed an entire industry. And yeah, we're even going to touch on what this means for the future job market.
It is pretty wild how a field that seemed, I don't know, kind of niche suddenly has the whole world's attention. And you're right, it's not just about the tech itself. This is about getting to the bottom of how we learn, how we adapt, how we make decisions. For the Nobel Committee to recognize AI this way, it really shows you how fundamental these concepts are becoming.
To everything. For sure. Okay, let's kick things off with something I'm guessing we're all familiar with.
Hmm.
NVIDIA. They're everywhere you look these days, right? Those graphics cards that gamers go crazy for. Well, get this. NVIDIA just blew past Microsoft. They're the second biggest company on the planet now, right behind Apple. And you want to know what's fueling this rocket ship? AI.
And the story there. Total twist of fate. See those GPUs, the graphics processing units, they weren't even made for AI. Nope, their whole purpose was to make those explosions in video games look crazy realistic. But then you have researchers like Geoffrey Hinton, one of our 2024 Nobel Prize winners. He saw something nobody else did.
Wait, are you saying that back in 2009, Geoffrey Hinton, the AI expert, needed free GPUs from NVIDIA for his research? And they said no. Unbelievable. Talk about a missed opportunity.
The irony is not lost on me, that's for sure. Hinton, he used their GPUs anyway. And by 2012, he and his students, they had this breakthrough, built an AI that could teach itself to recognize images. And it depended heavily on NVIDIA's own CUDA platform. I can only imagine the light bulb moment over at NVIDIA HQ. They were sitting on a gold mine and didn't even realize it.
So their gaming tech was the secret to AI's big break.
Yeah.
Now, that's a plot twist if I've ever heard one. Let's back up a sec, though, because I know some folks might be wondering, what exactly are these artificial neural networks? Sounds complicated, but is it really so different from how our brains work?
That is the million-dollar question, and it gets right to the heart of why AI is so captivating. Picture the human brain, right? But instead of neurons firing, you have algorithms crunching data. Basically, it learns from experience, just like you or me, but instead of biology, it uses math and a whole lot of data.
So instead of me showing my dog 1,000 pictures of a squirrel before he finally gets it, we're showing an AI mountains of data so it can spot patterns and make predictions.
You got it. But what's really cool is that this whole neural network idea, it's not even new. We're talking the 1940s. It wasn't until the 1980s, with more computing power and researchers like John Hopfield, our other 2024 Nobel laureate, that things really took off.
So Hopfield, he's like the godfather of making these neural networks actually work in the real world. What was his big contribution?
Hopfield, he came up with what's called the Hopfield network. And this is where the physics connection really starts to shine through. He used straight up physics to build a model that let neural networks learn from incomplete data.
Hold on, incomplete data. Like a puzzle with some pieces missing. How does that even work?
Imagine a blurry photo. Maybe it's a cat. Hopfield's model helps the computer fill in those blanks, uses what it knows about cats, the ears, the eyes, the fur, to make an educated guess, like a next-level guessing game. But instead of gut feelings, it's physics calling the shots.
Okay, that is seriously cool. But something tells me it doesn't end there. Hinton, he took this even further, didn't he?
You know it. Hinton, he brought in this concept called hidden layers, did it with something called the Boltzmann machine. It's a fascinating idea. Think of these hidden layers, like the AI's subconscious, you know.
All right, now you've got my attention. Tell me more.
Yeah, so with these hidden layers, the AI can do more than just recognize patterns. It can actually make predictions. It can even come up with completely new information. Instead of just seeing a cat in a picture, the AI, it can imagine that same cat, different pose, different background, maybe even, wearing a little hat or something.
Okay, now that's both hilarious and kind of scary at the same time. So that's how we got from those early neural networks to like ChatGPT writing poems and DALL-E making those crazy art pieces. It all comes down to these hidden layers.
You got it. Like unlocking a whole new level in the AI world. But speaking of unlocking things, I bet you're wondering about that connection we keep teasing, the physics behind it all. I mean, how often do you see an AI breakthrough win a Nobel Prize in physics I?
You read my mind. That's the part that really threw me for a loop. Help me out here. What does physics even have to do with AI?
It's all about the foundation, the underlying principles that make all this incredible stuff possible. Those neural networks we're talking about, they're more than just lines of code. They're built on, get this, real concepts from the world of physics.
All right, lay it on me. Give me Physics 101 for AI.
Okay, so picture this. You've got three branches of physics that are playing a big role here. First up, biophysics. That's using math and physics to figure out how the brain itself works. Remember John Hopfield and that groundbreaking network of his? His inspiration came straight from biophysics.
So, like, we're reverse engineering the brain's wiring diagram, but instead of scalpels and microscopes, we're using equations.
Exactly. Then there's statistical physics. This one helps AI make sense of all that data. And we're talking massive amounts of data, billions, trillions of data points. Statistical physics gives AI the tools to sort through it all, find the patterns, pull out the good stuff.
So it's like finding a needle in a haystack, but the haystack is the size of, like, Jupiter. And AI, thanks to physics, has a really, really good metal detector.
That's a pretty good analogy. And last but not least, we got to talk about computational physics. This one's the engine that makes it all go. All those crazy complex AI models, they need serious power, the ability to crunch numbers like nobody's business. Without advancements in computational physics, AI, well, it wouldn't even be a blip on the radar.
So it's like physics is the wind in AI's sails, pushing it forward. We've covered a lot of ground here, history of neural networks, their roots in physics, but let's bring this back down to earth for a second. How is this AI revolution actually playing out in the real world? And I don't just mean fancy gadgets, although those are fun too.
Oh, AI is already everywhere. And this is just the tip of the iceberg. Think about something we use every day. Siri, Alexa, those helpful voices on our phones in our homes. They might seem pretty basic, but behind them, sophisticated AI algorithms, all powered by neural networks, understanding our questions, talking back to us in a way that's almost, well, human.
It's true. I use those all the time. Never really stop to think about the science happening behind the scenes. It's easy to take it for granted, but it really is amazing when you think about it.
And it goes way beyond voice assistants. We're talking medicine. AI can analyze medical images, helps doctors find diseases like cancer earlier, more accurately. In some cases, AI is even outperforming human experts at certain things.
Now, that is what I call a game changer. Early diagnosis, accurate diagnosis, that can make all the difference. What else? What other areas are being impacted?
Oh, tons. Remember we talked about AlphaFold earlier? That's AI tackling a problem that stumped scientists for ages. This system, built on the work Hinton did, can actually predict the 3D structure of proteins.
Full disclosure, I'm not a scientist. Why is knowing the shape of a protein so important?
Okay, imagine being able to design life-saving drugs with the same precision an architect designs a skyscraper. That's AlphaFold. Proteins, they're the building blocks of, well, us. And their shape, that 3D structure, it determines how they work. If we can predict that structure accurately, game over. Faster drug discovery, faster development. We could be talking about cures for diseases we thought were impossible to treat.
Okay, so AI could help us cure diseases faster and more effectively. Mind officially blown. Feels like AI is popping up everywhere. What other fields are being transformed?
Seriously, it's amazing how fast it's spreading. Astronomy, AI is crunching huge data sets, helping us understand the universe, climate change, analyzing complex climate models, trying to figure out solutions. And of course, self-driving cars. AI is doing a lot of the heavy lifting there, navigating roads, avoiding obstacles, making those split-second decisions.
It's like AI is becoming this invisible force behind, well, everything. We talked a lot about the good, but what about the downsides? Some experts are worried about AI's impact on jobs. What are your thoughts?
It's true. Every new technology comes with challenges, and AI is no different. The IMF, they estimated that almost 40% of jobs worldwide could be affected by AI in the next few years.
40%. That's a huge chunk of the workforce.
Hmm.
Makes you wonder how we prepare for that kind of shift.
It's definitely something we need to be thinking about. Some experts think AI is going to create a bunch of brand new jobs, jobs we can't even imagine right now. Others say we need to rethink education, rethink job training, get people ready for this AI-powered world.
It's like we're standing on the edge of something brand new. Full of possibilities, but also a lot of unknowns. It's a lot to take in.
It is. But this isn't the first time we've faced big technological change. And we've always figured out a way to adapt. The key is to be excited about the possibilities, but also, think things through carefully.
It's a lot like you were saying before about NVIDIA with their gaming tech. Nobody thought that would be driving AI. It just goes to show you can't always predict these things.
It's the butterfly effect, global scale.
Right.
I mean, who would have guessed that a physicist studying the brain back in the 80s would be laying the foundation for, well, all of this? AI that could change everything.
It really is something. What we thought was just about better graphics turns out to have these huge ripple effects.
And that McKinsey report, the one we talked
Yeah.
about, they're predicting generative AI, the kind that can make new stuff, text, images, even music, could add trillions to the global economy every year.
Trillions.
Yeah.
That's more than some country's entire economy. It's almost impossible to imagine that kind of impact.
Think about it. A world where AI helps us design medicine, personalized to you. Hyper-realistic virtual worlds. Imagine AI composing symphonies, but tailored to your taste.
Whoa.
We're not just talking about tools here, we're talking about a totally new way of creating, experiencing.
Exciting and a little scary all at the same time. Like we're standing at the bottom of this huge mountain, no idea what we'll find when we start climbing,
And like any big adventure, there are going to be challenges.
for sure.
But it's the unknown, right? That possibility of finding something totally new, something revolutionary, that's what makes it so exciting.
So we started this deep dive with a bit of a head scratcher, AI winning a Nobel Prize in physics. But as we've gone deeper, the history, the science, the impact, it's clear that this wasn't just about one award.
It's about recognizing how everything's connected, these different fields pushing each other forward.
Yeah.
It reminds us that sometimes the biggest breakthroughs, they happen in the margins, where you least expect them.
It makes you wonder, what are we overlooking right now? What seems small today, but could be the next big thing.
That's the beauty of science, right? There's always something new to uncover, some connection waiting to be made.
Who knows? Maybe we'll be back here in a few years doing a deep dive on that Nobel Prize-winning discovery.
I love that.
Until then, stay curious, everyone. We'll catch you on the next deep dive.